Okay, so I think it's visible.
Yes, it is visible.
Okay, fine. So see, the first chapter of this paper is metal metal ligand in transition metal complexes. So you have known very well what is metal, especially it is generally d block element, and ligand is nothing but it is having lone pair of electron or it has negative charge, and generally ligands donates its electron to central metal atom in order to getting you can say in order to getting stable complex. Okay, so you are having see d orbital of the metal is used with the ligand. So now see, this is your syllabus in the chapter 1. These are the topic crystal field splitting diagram, especially for octahedral, tetrahedral and square planar complexes. Also we will going to discuss tetragonal distortion from octahedral symmetry. Then we will going to talk two important series, spectrochemical and nephrologic series, and then move to the application part of CFT, and at the last we will going to do ligand field theories, make a study of ligand field and molecular orbital theory for metal complexes. So now see, before discussing CFT, crystal field splitting theory, it is important to know about d orbital, shape of the d orbital, because metal having c d orbital, there are 5 d orbital. So look at this slide. It is a d orbital, shape of the d orbital.
DJ square in fast.
So here what happens? In this case, see, there are 5 d orbital. So first one is, you can say,
DJ square.
yeah, dz square. So lobes of this
Then
orbital
EX
is
square
in the
A
axis.
minus Y square.
See, this is having dz square. Okay, its lobe is on d orbital. Then another one is d x square minus y square. This is a dz square followed by this is a dz square. This orbital is here also lobes is in the axis. See, dxy. This is dx square minus y square. Lobes. This is a double dumbbell. D orbital is a double dumbbell. Its lobes is on x and y axis. Here it is on z axis. Now this is called dxy. This is dyz, and this is dzx. So in this case, see what happens actually in the crystal field splitting. So see, CFT actually describe breaking of orbital degeneracy in a transition metal complex is due to presence of ligand. See, there are 5 d orbitals. So initially, in a free metal ions, all the 5d orbital having similar energy. There is no splitting. Okay, but once ligand is approaches to metal, so at that time there is a repulsion between metal orbital and ligand, and because of that repulsion, electrons, see whatever number of electrons are there in d orbital and whatever electrons with ligand, between these two there is a repulsion, and because of this repulsion d orbital may not remains in a degenerate state, it will undergo splitting. It is split into two sets. So that's why you are getting C splitting. So crystal field splitting is because of the presence of once ligand approaches to metal, at that time C splitting is take place. Otherwise splitting cannot be done. Otherwise, all these 5d orbital having similar energy in metal, but once ligand is approaches to metal, so this orbital gets splitted. So CFT described the breaking of orbital degeneracy, and that is because of the ligand in a transition metal complex due to presence of ligand. So what happens? See, it is a octahedral complex is having 6 ligand which are surrounded to metal. So once ligand approaches to metal, it is close, it is come in contact with metal. So at that time there is a repulsion between electrons which are present in a d orbital and electrons which are available on ligand. Okay, so between these two there is a repulsion, and that's why this degeneracy of orbital gets break down and d orbital gets splitted. So this is the main reason in crystal field splitting why you are getting splitting. So there is a repulsion between metal electron and electrons on the ligand. So because of this repulsion, it experience more in the case of, so this such repulsion factor is again see experienced more by this orbital dx square minus y square and dz square orbital, and if repulsion is more then its energy is higher, and that is because reason is see, lobes of this orbital is, or you can say point these orbitals as they point towards axis along the direction of ligand. Lobes of this orbital are along the direction of ligands, or you can say towards axis, and because of this you are getting see this set having more energy. So therefore this set of dx square minus y square and dz square having higher energy in a spherical crystal field. At the same time, see lobes of these three orbital dxy, dyz and dxz orbital experience less repulsion because this orbital is directed in between axes. See, this is the main difference between these two. One is in between axis and second one is along the axis. See, look at here. Dx square minus y square lobes of this orbital is along the axis. Okay, it is in the direction of ligand, that is along the axis, and here it is in between axis. And therefore it experiences less repulsion. So therefore dxy, dyz and dxz having lower energy as compared to dx square minus y square and dz square. And hence this 5d orbital are splitted into two set because see they are having different amount of repulsion, two orbital having higher repulsion, three orbital having lower repulsion. So therefore they are splitted from average energy in a spherical field. Whatever average energy center is there, so from that this orbital are splitted. So thus repulsion in octahedral complex is you are getting two different set, that is called one set which is having dx square minus y square and dz square. This is a one set dx square minus y square and dz square. This is we called EG set. G represents G dot, that is symmetry which is present in octahedral field. And other three orbitals, that is dxy, dyz and dxz, that experience lower repulsion. So this set is of orbital is, you can say, T2G. This is a T2G. It is called triply degenerate and this is called doubly degenerate. In this way, see the 5d orbital gets split into two set. So my question is, see, is there any splitting is take place in a free ion state?
No, they are non-degenerate.
Yes. So when splitting is occur?
Degenerate occur. They
Yeah,
are degenerate.
when ligand come close to metal.
Metal, then there will be repulsion occur.
Okay, why
At
dx
close
square minus y square and dz square having more repulsion, experience more
because
repulsion?
because they are along z-axis and ligand coming from z-axis along the z-axis.
Yes, ligand are also, see ligands is in octahedral structure. What you can do, see this is your octahedral structure. Look at here. This is your octahedral structure, and so in the octahedral structure, see ligand is also present in the axis. See these are the six ligands where its electrons are there. Electrons of ligands are here. Okay, so this is, you can say, z axis, this is, you can say, x and y. So here what happens is ligands dz square orbital is over here. See this is your dz square. So lobes of z orbit dz square orbital and electrons, or you can say ligands, both are along the axis, and therefore there will be more repulsion. Here also dx square minus y square orbital is present in x and y axis, and lobes of ligands are also on the axis. So in this case, see, this is along the axis, lobe जो है वो along the axis है, and therefore what happens is there will be more repulsion experienced by dx square minus y square and dz square, and therefore this set having higher energy, whereas remaining three having lower energy. Because what happens in the case of dxy, dyz and dxz, so here in this case See, ligand is there on x and y axis and z axis. This is your x axis, this is y axis, and this is z. Now the xz is present between axes. See, this is called the xz. And therefore, see here, lobes of the orbital is present in between axes and ligand are in axis, and therefore it experiences less repulsion, and therefore it is having lower energy as compared to EG set. This is called T2G set. So this set is, you can say, T2G, and earlier one it's EG set. So now what happens? See here, splitting is take place in such a way that you can have a 2 orbital with higher energy and 3 orbital with lower energy. But this is called T2G set, and this is called EG set. Now see here, this is free metal ions where all 5 d orbitals having similar energy. They are non-degenerate, and this is the case of in a spherical field.
Because they are symmetric. In spherical field, they are symmetric.
Yes, in a spherical field, you see ligand approach is close to metal, so that is called spherical field. So in this way, see, this is splitting is take place. Now this center is called, see here, average energy center is called Berry center, or you can say center of gravity. What is definition of Berry center, or what is, you can say, center of gravity or average energy center? So see, this center is, you can say, it is a average energy center. Average energy center is called Berry center. इसका मीनिंग ये है, सी on this line, on this center, from which on both the direction equal amount of energy is distributed, इसलिए इनको एवरेज सेंटर बोलते हैं. यहाँ पे 3 ऑर्बिटल है, ऊपर जो है वो 2 ऑर्बिटल है, तो दोनों साइड से इक्वल एनर्जी डिस्ट्रीब्यूशन होगा, इसलिए ये जो मिडिल वाला सेंटर है दैट इज कॉल्ड बेरी सेंटर. दिस लाइन इज, यू कैन से, इट्स अ बेरी सेंटर because equal energy distribution is take place from this center. So this is your Berry center. वो कैसे पता चलेगा इक्वल एनर्जी डिस्ट्रीब्यूशन है? तो पूरा जो डिफरेंस है, डिफरेंस बिटवीन दिस टू ऑर्बिटल, द स्प्लिटिंग इज octahedral. It is, its value is octahedral. Delta, this is a difference, delta, or it is equal to, see, 1 delta is equal to 10 dq. So either you can write down 10 dq or you can write down 1 delta. This is a difference between these two orbital. Now EG set, its orbital is increases. So what it is increases in what amount? कितना dq है?
The question. So please
E-
repeat, please.
yeah, for EG set of orbital, its energy is increases by how many factor? By how many dq?
6 dq.
Yes, it is by 6 dq. So total आपके पास कितनी orbital है EG set में?
2 orbitals.
2 orbital. So 1 orbital with 6 dq increase होगा, तो total 2 orbital है तो कितना increase होगा?
12 dq.
So आपके पास ही 2 orbital है, so it is 2 into 6 dq. That is called 12 dq. Okay, how Berry center is there in middle, that we prove it. So it is increases by total by 12 dq amount energy. Now see, यहाँ पे 3 orbital है, so its energy is decreases, minus sign indicate decreasing in energy, so it is decreased by 4 dq. Okay, it is decreased by 4 dq. So 4 dq with 1 orbital, तो ऐसे कितनी orbital है?
3 total minus 12.
So it is ऐसे 4, माइनस तो देखना ही नहीं है, वो तो डिक्रीज होता है इसलिए माइनस साइन लिखा है. So it is 4 dq into 3, that is again 12 dq. तो आप दोनों साइड एनर्जी देखो, ऊपर भी 12 dq है, नीचे भी 12 dq है, that means equal energy distribution is there, and that's why this center is called Berry center. Definition of Berry center is, it is a average energy center from which on both the side there is a equal energy distribution, and that's why, see, this center is, you can say, it is a Berry center. Okay, is it clear what is definition of Berry center? It is a equal energy distribution center. तो सेंटर से दोनों साइड जो एनर्जी है वो इक्वली डिस्ट्रीब्यूट होगी. सो दिस इज कॉल्ड बेरी सेंटर. नाउ इज इट क्लियर? This diagram is
Yes, sir. It has been
Yes,
clear to
sir.
me.
okay. So if you want to fill, see one electron in an octahedral complex, then it is goes into which orbital? It is goes into EG orbital or into T2G orbital.
Easy, easy orbital.
Yes, of course, it is enter into EG orbital. EG orbital होगा या T2G?
T2G.
T2G
It's
because
T2
see
because
low.
there is a lower energy. Because there is lower energy.
Yes, so lower energy orbital fill first. Okay, तो आपका फर्स्ट इलेक्ट्रॉन है, इट इज एंटर इनटू T2G. सेकंड भी T2G में जाएगा, थर्ड भी उसमें जाएगा. उसके बाद आपको देखना है कि इसी वेदर कॉम्प्लेक्स इज हाई स्पिन और लो स्पिन, तो उस हिसाब से डिसाइड करेंगे कि पेयरिंग करना है या उसको ऑन पे रखना है. बट इट इज फर्स्ट T2G orbital is fill and then EG orbital is fill. So splitting of D or degenerate level in the presence of ligand is known as crystal field splitting. So difference between the energy of T2G and EG level is denoted by octahedral splitting, that is delta octahedral. Here subscript O stands for octahedral. So some ligands tends to produce strong field here, thereby and causing large crystal field splitting, whereas some ligand may tends to produce weak field ligands and therefore they causing small splitting. So the splitting is depending on strength of the ligand. Okay, which type of the ligand is there. So application part is of course there in another chapters, but here we will going to cover it. So there is no need to go for that chapter separately. तो यहाँ पे चलो इसकी एप्लीकेशन देख लेते हैं कि नाउ दिस CFT इज सी वेरी क्रिस्टल फील्ड स्टेबिलाईजेशन एनर्जी. क्रिस्टल फील्ड स्टेबिलाईजेशन एनर्जी इज डिपेंड्स ऑन टाइप्स ऑफ द स्प्लिटिंग. एक तो ऑक्टाहेड्रल है, टेट्रागोनल है, कौन सा है. ओके, इट इज डिपेंडिंग ऑन टाइप्स ऑफ स्प्लिटिंग. This is also depending on strength of ligand
And charge, positive
yes,
charge.
strength of ligands, that is called oxidation number. Okay, it is depending on oxidation number of metal.
Atomic number. Higher atomic number means higher CFC.
It is depending on principal quantum number of d orbital. Principal quantum number of d orbital, that is n value. 3D है, 4D सीरीज है एंड 5D है, तो 5D की स्प्लिटिंग ज्यादा होगी एज कंपेयर टू 4D ऐसी तरफ. So see, these are then also chill ligand, strength of chillating effect of ligand, chillation. So these are the various way CFT is depends. So what happens in the case of strong ligand? See, strong ligand कैसे बोलोगे? The ligands.
Spin pairing hole.
Okay,
There
so
will be
that is nothing but let's say ligands which is having, you can say ligands. This is a spectrochemical series. Okay, that is called ligands are arranged according to increasing order of their field strength. तो ये जो आपका लिगेंड है यहाँ, it is a spectrochemical series where ligands are arranged according to increasing order of, or you can say decreasing order. Here it is written, this series is written by taking increasing order. So ligands are arranged according to you can say increasing order of.
left to right increasing order.
Yes, ligands are arranged according to increasing order of field strength. So series obtained which are called spectrochemical series. So सबसे ज़्यादा strong ligand ये है CNN, CO, अमोनिया भी strong है. तो ये सारे जो ligands है नाइट्रोजन वाले सारे, these are the strong ligands. H2O onwards, see, these are the
Sir,
weak ligands. Yes.
sir, hydroxy is more strong than H2O.
H2O is a, see, H2O ligand जो itself है H2O, it is a weaker ligand. H2 लिखा है ना, H2 is a weak ligand. This is the oxy ligand. ऑक्सीजन है. Then इसे हाइड्रोक्सिल तो यहाँ पे आएगा. हाइड्रोक्सिल is a too much weak ligand. Okay, OH minus is a weak ligand. Even NO2 है, इसमें ऑक्सीजन जो डोनर है तो it is a weak ligand. ONO. So this is the order. Hydroxyl is of course weaker than that of H2O. स्ट्रॉन्गर कौन कौन से हैं? CN है, एमोनिया है, NO2 है. these are this is strong ligands. CO है, pyridine है, ethylene diamine है, bipyridyl है, phenanthrene है. So these are the stronger ligand. H2O onwards they are weaker ligand. Okay. I minus 2 H2O जो है, these are the weak ligand. And NCS2 CO are strong field ligand. Okay.
Yes, sir.
So what happens is whenever strong ligand is present, so at that time pairing is take place. And if you having weak ligand, then the electron remains unpaired. Okay, so now, so depending on that, see whether you can have a complex is you can say strong field complex or weak field complex. Okay, so here if you're having strong ligand, then what happens? Pairing is take place. So if strong ligand is present, strong field ligand is present, then complex is you can say it is low spin. Pairing take place, pairing of electron take place. And if weak field ligand is there, then this complex is called high spin complex. So pairing does not take place, electron remains unpaired. Here this pairing is not take place. So what you can do, see if you having D1, one electron is there, you can fill up it into octahedral geometry with high spin and low spin. First you go for low spin, that is ligand is strong, and here it is a high spin where ligand is weak ligand. Here it is a weak ligand. Here it is a strong field ligand. So in the case of D1, what happens? Of course, in an octahedral structure, you can have a T2G having lower energy as compared to EG. So what happens in the D1? Where
6
is
DQ.
that electron is goes? This electron is
T2G.
into T2G, yes. And one electron is there, so you can have a same structure. Whether you can go for high spin complex or low spin complex, both having same configuration. But if you having D2, then what happens? This is
D2 be
D.
same. D2 will be same as D1.
D2 as it is D2 में क्या होगा it of course T2G fill first तो दो इलेक्ट्रॉन इसमें आएंगे लो स्पिन है तो यहाँ पे पेयरिंग होगा सी ऐसे आएगा ऐसे नहीं आएगा ओके इलेक्ट्रॉन गेट्स पेयर बट इन द केस ऑफ high spin complex electron remains unpaired in this way. What is the case of D3? Low spin में
First orbital paired and second orbital single.
yes यहाँ पे तीनों सिंगल रहेंगे ऐसे 4D4 this is D4 here it is electron remains unpaired so here one electron and one electron goes to EG this is T2G यहाँ पे T2G4 आएगा यहाँ पे T2G3 and EG1 so see in this way you can have suppose seven electrons are there how it is filled in the low spin complex
T2, T2G will be all paired and EG orbital has one electron.
yes so EG having one so T2G6 and EG orbital having one electron but here
T2G and EG all be filled and the first two orbitals of T2G will be paired.
yes so it's a T2G 5 EG2 okay in this way so in this way the electron gets arranged into different orbital so if you want to calculate crystal field stabilization energy so this is the formula see energy of EG orbital electrons in EG orbital electrons which are present in EG orbitals are multiplied with 6 dq because its energy increases by 6 dq plus electrons in T2G orbital are multiplied by minus 4 dq because its energy decreases by 4 dq plus you can have a see, number of electron pair that is called pairing energy so you are getting crystal field stabilization energy for different complexes suppose आपके पास cobalt NH3 6 टाइम NH3 जैसी स्ट्रॉन्ग लिगेंड +2 ऐसा कॉम्प्लेक्स है तो इसके लिए CF/SC काउंट करना है कैलकुलेट करना है तो कैसे कैलकुलेट करेंगे
At first, outer cell electron configuration of cobalt will be determined.
हाँ
Then we can calculate.
हेलो खोला गया ना ना कौन घर छोड़ी फोन करो हमने तुमने थोड़ी बार में 15 मिनट में करो हाँ so see this is CONH3 6 time plus 2 okay CONH3 6 time plus 2 so this is a strong field so which orbital is there it is cobalt is atomic number is 27
D8 electron configuration.
atomic number is 27 so it's argon 18 4s2 3d7 this is the configuration of cobalt it is a cobalt Now you can have a Na3 is a neutral ligand, so it is a CO plus 2. So 2 electron gets removed from 4s orbital. So again it is a D7. Okay, it is a D7 configuration. Now this is a strong field ligand, so electron remains in a pair. First, which orbital is filled?
T2G orbital will be paired and EG orbital has single electron.
Yes, so T2G filled first here. It's a T2G. There are 7 electrons, so you can have a 6 electron first enter into T2G and 1 electron in EG. So crystal field stabilization energy equal to 6 into 6 dq plus 1 into minus 4 dq plus number of pair, that is 3 pair is there, so you
Plus
can
P.
write down 3p. Okay, number of pair is 3. That is called pairing energy. So what happens? Crystal field stabilization energy is equal to 6 into 6, 36 minus 4 dq, that is 32 dq plus 3p. 6 dq into 6. 6 into 6, that is 36, and 1 into 4, that is minus 4, so it becomes 32. Or you can have a C, if you want to write down in octahedral splitting unit, then you can have a 3.2
सर
octahedral
यहाँ
splitting.
तो 4 into 6 होना चाहिए, T2G नीचे है.
सॉरी, थोड़ा अगर इसमें भी गलत लिख दिया कि जो T2G नीचे है तो 4 होना चाहिए. ऑफ कोर्स करेक्ट. इट्स in the case of CO NH3 6 times plus 2, oxidation state of cobalt is plus 2, so therefore it's a D7. So you can have a T2G field first, its energy decreases by 4 dq, and 1 electron is goes into EG orbital, its energy increases by 6 dq. So crystal field stabilization energy is equal to 6 into minus 4 dq. Good. Its energy decreases plus 1 into, you can say 6 dq plus 3 pair is there, so it's a 3p. So what is your answer? 6 into 4 minus 24 dq plus 6 dq plus 3p, that is minus 18 dq. Now it is correct?
Yes, sir.
Okay. What's about the high spin complex? Suppose it is COH2O6. H2O is a ligand. It is a high spin complex, suppose, where ligand is a H2O. COH2O is a ligand. Again, see, it is a D7 system, but it is a high speed. So how many electrons is entering into T2G? High spin complex is there.
In T2G, then there will be two orbital will be paired and one orbital or only single electron.
So say T2G having 5 electron and EG having 2 electron. So therefore crystal field stabilization energy become equal to CFSC is equal to 5 into minus 4 dq plus 6 2 into 6 dq plus you can have a 2 pair. So crystal field stabilization energy become equal to minus 20 dq plus 12 dq plus 2p. So it become minus 8d cube. Okay, or you can see also write down in octahedral splitting unit crystal field stabilization energy is equal to minus 1.8 octahedral splitting plus 3p. Here you can write down crystal field stabilization energy is equal to minus 0.8 octahedral splitting plus 2p. Okay, both are same. Is it clear?
Yes, sir.
Okay, so in this way, so you can calculate crystal field splitting. So now this is the case of, you can say, octahedral complex. What happens in the case of say, tetrahedral complex? If you go for crystal field splitting of tetrahedral complex, then in the
In tetra,
tetrahedral complex, what happens?
ligand will come along the direction along the between axis,
Yes, ligand which is comes in between the axis. Yes, that is very important difference between
and
octahedral.
tetrahedral is centrosymmetric. There will be no U and G. Now,
Yes, I is absent in tetrahedral. This is second thing. So here splitting of five-fold degenerate d orbital of metal ion is into two level again in a tetrahedral crystal field. That is two set. It is you can say T2 and is E. There is no Girard on Girard. You can simply write down it's a T2. Okay, it is T2. T2 and you can say E set. Now here electrons of dx square minus y square and the z square orbital are less repelled by ligand as compared to electrons of dx square xy dyz and dxz orbital. See in previous case what happens?
previous case was opposite that.
Yes, opposite. Electrons of the x square minus y square and the z square experience more repulsion, and that's why the energy of each such gets increases. But here it experiences less repulsion, and therefore its energy is decreases. But T2, that dxy, dyz, and dxz have experienced more repulsion, so that's why its energy increases. As a result, you can have a see splitting of two set take place in spherical field. So there are only the four ligands in a tetrahedral complex, and therefore total negative charge of four ligands and hence ligand field is less than that of six ligand. Now when you do comparison with octahedral, so in octahedral there are six ligand. So total negative charge of that six ligand and whatever field strength of that ligand, it is much higher as compared to uh, tetrahedral. And therefore in which case splitting energy is higher? ऑक्टाइडल की
Second,
ज्यादा
third,
होगी
second,
या
second, third.
नहीं?
Octahedral का ज्यादा होगा. Second, third,
ऑक्टाइडल के ज्यादा होगा, yes. And
second, third
जो
more.
yes, second third more, yeah, octahedral is compared to tetrahedral. Also the direction of orbital does not coincide with direction of the ligands approaches to metal. octahedral में same direction में था, but यहाँ पे क्या होगा, see directions are in a especially this is in between the axis. Here whatever direction is there, so they are not going inside. So you can have a here if you draw its geometry. So tetrahedral geometry is like this type. This is you can consider cubic box. So in the cubic box, metal which is there in the center of this box. Here you can take a metal. Here you can have a metal over here. Now see ligands are in the tetrahedral field. They are present at four corner of the tetrahedral. Yes. Is there any? See, metal is in the center. This is a cube. We have imaged the cube, and then in this cube, we are going to write down the particular uh, field, or you can say tetrahedral geometry. So here in the tetrahedral geometry, whatever very center is there, so you can have a see four ligands which are at over here. One is here, second one is here, third one is over here, and fourth one is here. So these are the four ligands. Look at here. Okay, this is the metal and these are the positions of ligand. Now see, your orbitals are x is over here. This is the x orbital. Sorry, this is the x axis. This is you can say y axis, and this is you can say z axis. So you look at here. See, ligands and axis are different. They are not along the axis. And another very important things over here is two d orbitals are present on axis here, and remaining three orbitals are on the edge center of cube. यहाँ पे जी ये सारे एज है, और ये जो इनका जो फेस है, तो फेस सेंटर में दो ऑर्बिटल आएगी. Two orbitals are present in a face center. This is the face, and this is you can say edge center. It is edge center. So here what happens? X, Y, and Z axis, they are in the face. Okay. टोटल जो फेसिस में कौन कौन से एक्सिस है, और फेसिस के सेंटर में से कौन से एक्सिस पास होती है? एक्स, वाई एंड जेड एक्सिस आर पासिंग थ्रू
Center of face.
yes, center of face. और बाकी के जो है वो इज प्रेजेंट ऑन सेंटर ऑफ एज. जो बाकी के आपकी जो तीन एक्स वाई जेड तो मैंने लिख दिया, तो उस हिसाब से एक्स स्क्वायर माइनस वाई स्क्वायर डी एक्स स्क्वायर माइनस वाई स्क्वायर एंड डी जेड स्क्वायर आर प्रेजेंट ऑन एक्सिस, आर प्रेजेंट ऑन एक्सिस. एक्स वाई एक्सिस में होगी ऑर्बिटल. ओके, एक्स और बाकी की जो है तीन ऑर्बिटल दैट इज प्रेजेंस इन बिटवीन एक्सिस, दैट इज इन द एज सेंटर. बाकी की जो तीन ऑर्बिटल है डी एक्स वाई, डी वाई जेड एंड डी एक्स जेड आर इन एज सेंटर, passing through its center. So in tetrahedral complex, none of the d orbitals are in direct contact with ligand. Octahedral में definitely it is passing through C ligand, तो direct contact में थी. But here none of the d orbital is direct contact with ligand. But dxy, dyz and dxz are near to the ligand. Look at here. जो एज सेंटर में है वो लिगेंड की नजदीक है, क्योंकि लिगेंड भी एक एज के कॉर्नर में है. Okay, so dxy, dyz and dxz are near to the ligand orbital, whereas dx square minus y square and dz square are away from ligand. Here see dxy, or you can say dyz and dxz are near to ligands, and dx square minus y square and dz square are away from ligand. तो किसमें ज्यादा रिपल्जन होगा?
XY, YZ, and XZ.
Yes, so they experience more repulsion, and that's why energy of T2 set is increases again by 4 dq because of the definition of Berry center. So 4 into 3, that is total increasing amount is 12 dq, and energy of T2 set is decreases by, sorry, E set, E E set is decreases by, you can say 6 dq. So total 2 orbital is there, so 2 into 6, it is a 12 again. So this is called center of gravity line, or you can say it is a barycenter. So in this way it is exactly opposite to that of the you can say especially octahedral splitting. Okay, it is totally opposite to that of octahedral. Now, so in free metal ions, all these d orbitals are degenerate, but when it is come in contact with you can say here you can have a see 5 d orbitals with same energy. This is the case of free metal ion, but when it is come in contact with ligand, so in a spherical field in a metal complexes, this degenerate orbital gets split into two lines, two set, T2 and E set. So crystal field, if you compare crystal field splitting energy with that of you can say octahedral, then it become tetrahedral splitting energy become 4 by 9 times to octahedral. So octahedral energy यहाँ ज़्यादा है. So octahedral energy is more as compared to tetrahedral. Okay, octahedral splitting is higher as compared to tetrahedral. So thus the repulsion in tetrahedral complex again gives two set, T2 and E set. The crystal splitting in tetrahedral complexes is smaller as compared to octahedral because there are only 2/3 as many ligands and they have less डायरेक्ट इफेक्ट ऑन दी डी ऑर्बिटल. दो चीजें, तो उसमें डायरेक्ट इफेक्ट थी ऑक्टाइडल में, यहाँ पे लेस है और लिगेंड भी कम है, दो लिगेंड कम है. सो द रिलेटिव स्टेबलाइजेशन इफेक्ट ऑफ ई विल बी -6 dq डिक्रीज होगा और जो T2 सेट है उनका 4 dq से इंक्रीज होगा. So similar way you can do calculation for tetrahedral crystal splitting. So is it clear up to here?
Yes, sir.
Okay, fine.
Yes, sir.
Yes. So thank you very much for joining.
Thank you.